Hey, welcome back to Markov Method, and this is officially lesson number 4. First off, big congrats to you. You built a fully working calculator in C#. That's not beginner stuff. That's real programming that you got there. But we kind of skipped a step. We didn't actually test the calculator in action last time. My bad. Totally on me. So that's exactly where we are starting today. We're gonna run it, break it, and see it work for real. Now, what else are we doing in lesson 4? Here's the game plan. First, we'll upgrade our calculator to handle decimals, so it's no longer stuck in integer number land anymore. Then we'll clean up our logic by introducing the switch statement. Super useful when you have options to pick from. Then we are diving into loops. For loops when you know many times, and for each loops when you're walking through stuff. And most importantly, we are going to start thinking like real devs. This means understanding how to break a problem into small little steps. That's algorithmic thinking, and it's what separates coders from code writers. So buckle up, crack your fingers, and get comfy because we are taking this project to the next level. Alright, intro's done. So let's fire up Visual Studio and put this calculator into work. I've already done that while we were waiting. So this is the exact code that we finished last time. We wrote it, we saved it, but we never actually ran it. So it's time to change that. Look up here at the Visual Studio. You see this green triangle at the top? That's your play button. And it starts what it's called a debugging session. Debugging? What is that? Debugging means run your code, see the output, and catch errors while it's running. It's like testing your car and you have the hood open so you can accelerate, brake, even drive if you want, and watch what's happening under the engine. I do not recommend driving with the hood open, let's say like this. So go ahead and hit that green button. Let's go! First test. Let's try to add something like 5, 4, and our operation will be add. Boom! Output is 9. Looks good. So we close the window and we open again. Now let's try to subtract 10. 3. Operation subtract. Result 7. Amazing! Everything is working. Let's multiply 3 and 3 multiply 9. We are still rocking. Now let's divide 10 by 2. So 10 to divide 5. We are going it. This is going good. And now let's try to break these on purpose. So divide 10 by 0. We should have an error. Dude, you can divide by 0? Nice! So let's do one more test. Let's type something weird like explode or banana for the operation. So 10, explode. Operation not recognized. Awesome! Error handling working as expected. But even though it works, let's be real, there are a few things we can improve here. First, it only works with integer numbers, so if you type 2.5, it crashes. It's not cool. Second, the code logic is getting kind of bulky. You see all these if, else, else. It's starting to feel like a spaghetti jungle. And lastly, we don't really reuse anything. There's no loops, no way to repeat the program unless you restart it. That's not cool also. But don't worry, we're gonna fix all of that step by step, starting right now. Let's get fancy and make this calculator work with decimals. So the issue that we have with numbers is right here and here. We are using int, which stands for integer, and that means no decimals allowed. So instead we are going to swap that for the keyword double. We go here and double, double, and double. Also in the convert to, let's convert to double. To double. And what is a double? Double is a data type that can handle numbers with decimal points. It's numbers like 2.5, 3.14, all that good mathy stuff. It stands for double precision floating point, but let's just call it decimal friendly for now. Also, notice that we are using to double instead of to int32, and that part matters a lot. You need to convert the user's text input into the proper double, or it won't work, because if you remember from our second lesson, if we declare a variable of type double, we need to assign doubles to it. We can only assign doubles to it. Before we had an int variable, so we would assign int values. And this is super important. Now let's run the calculator again, but this time let's go decimal mode. First, we will type 7.7, for example, and 2.2, and we will add 9.9. Amazing, it has decimals, it works, correct value, everything's fine. Now we had an issue with the division, so let's type 5, 2, and divide. Before, this would answer us 2, and now the correct number is 2.5. It's working, and this is the power of decimal. Now, just to test our safety net, let's try something that's not a number, like pizza. So, pizza, to enter, something broke. Did you type a number? Amazing, that's what we wanted to see. Our try-catch block is still working, even when we are using doubles. So now, our calculator is officially upgraded. It's smarter, it's more accurate, and won't explode when someone types a decimal. That's super, right? Next up, we will clean up that jungle of if-else statements, so it's time to learn about the switch statement. Alright, next upgrade, logic cleanup. Right now we are using a bunch of if, else, to figure out what is the operation that the user picked and do some calculations. It works, but it's kind of messy. Let's simplify that with a single switch statement. We are going to replace this whole code, where we check if it is an add, a divide, and so on, with a singular compact structure. I have prepared the code beforehand. It's something like this. So what's happening here? Instead of checking every case one by one, we just say, "Hey C#, switch on the operation," and match it to one of the predefined cases that we have it. And when you match it, run this little clean piece of code. And when you are done with it, just break out. And yes, you can still nest ifs inside these little pieces of code, like we had for the divide by zero logic. If nothing matches any of the predefined cases, we enter the default case. In our example is when we insert something that it's not a valid math operation. Now let's try it out to see if everything still works. So let's try to add 6 and 4. 10 is the result. All good. Now let's try divide by 0. 2, 0, divide. You can divide by 0. Now let's try to force the default case. So we are going to do 2, 2, and potato. Operation not recognized. That's fine, we are in the default case. Now let's try to add potato with pizza. Something broke, you did not type a number. So everything is running exactly the same, but the code much cleaner, easier to read, and much easier to maintain if we ever want to add more operations. And we will. Alright, the logic is polished. Let's move on and make the program repeat itself a few times without restarting it manually. It's time for loops. Up to this point, we have written code that does one thing once. But real programs, they usually repeat actions or work with multiple values at once. That's where today's two new superpowers come in. Arrays, to hold a bunch of related values, and loops, to do things over and over. Let's break this down from the top. First up, what's an array? Think of it like this. An array is like a row of boxes. Each box stores one value. Instead of making a new variable for each value, we group them all in one array. Let me show you what it looks like. So in your code, put the cursor here, type enter, and type string, square brackets, and type it operations, in plural, equals, brackets, and now type inside quotation marks, add, comma, then subtract, comma, multiply, comma, divide. So we have created one variable called operations, and we have packed 4 strings on it: add, subtract, multiply, and divide. We have used square brackets here to say, hey C#, this variable called operations is an array of strings. And then we added the strings separated by comma inside a block. Now we can read the values using a foreach loop. And we know that these will present a message to the user, so let's remove this and allow a foreach to iterate for every operation that we have to present the case to the user. So you type foreach, and then you can do it string, because each variable inside of this array is of type string, and let's call it op from operation, in operations, and then you close this and you open a code block. So this is telling C#, go to operations and run each one of the objects that you have inside and select one by one. And now you can do things with it. In this case, we are going to do console right line of the operation. Let's make it a little bit more pretty. So we will type this and this. We remove this and put a dash before introducing the operation that we want to introduce to the user, so we can see the difference. And this will make it go through the array, one item at a time, and print each operation on its own line. Let's run it to see. Type play, 1, 3, and now we have the 4 things that we had. If we can see, we have chosen operation from here, and then this part is running each one of the items inside the operations. Let's type add, and we should have 4. Everything working as expected. And now we are using a foreach for our operations. Now let's look at a for loop. This one is a little bit different. We use it when we want to repeat something a specific number of times. For example, let's run our calculator 3 times in a row without restarting the app. So let's code it like this. before the try catch, type for and type the following. Int I equals to 0, while I is less than 3, I plus plus, and open a code block. What do we have here? This means this part is a declaration of a variable inside the for. It will be called our iterator. It will start in the number 0 because we defined. The second is the condition while the for loop still acts. While the I, or this means the iterator, is less than 3. Do the code inside the brackets. And lastly, when you finish running the code, add 1 to the iterator. So we start at 0. 0 is less than 3. Yes, run this code. Then add 1 to 0. Is 1 less than 3? Yes, run the code. Then add 1 to 1. We have 2 now. Is 2 less than 3? Yes, run the code. 2 plus 1, 3. Is 3 less than 3? No, it's equal. So we get out of the for loop. To make it work, let's go to our complete try catch, select this, cut, and paste it inside. To make it visually, let's do it like this at the beginning. Console, right line, and put the $sign. This is run number, and you can use the iterator inside the for loop. So if you type brackets I, it will be available as a variable. Let's run it out. This is run number 0 because we start in 0. To add. This is run number 1. Let's put 3, add. This is run number 2, 4, add. And we are done. We only run 3 times. But we have presented here 0, 1, and 2. And we asked you to present it 3 times. We presented it 3 times. But it seems not so logical to present. You can do like this. And now it will show the correct number, at least a more natural number for a human eye. So this is 1. This is run 2. And this is run 3. Everything working as expected. Use for when you know exactly how many times to repeat something. Use foreach when you want to walk through a complete list, like an array. And use arrays when you have a group of related values you want to store together. There is another type of data that can store a collection of data called list. It's more commonly used than array, but in essence, both of them are collections of the same types of values. Like you could do something like this: list and of type string, operations has lists. And in this case, you will have to do something like with square brackets instead of curly brackets. Subtracts, multiply, divide. This will be useful for the future, but right now keep with the array approach. You now have tools to write code that scales, repeats, and reacts. Next, we take a step back and we will talk about the most powerful dev skill of all: how to think in little steps, also known as algorithmic thinking. So before we wrap up, it's time to talk about something way deeper than simple code. This is where real developers start to stand out. It's called algorithmic thinking, and no, it's not scary. It just means Can I break a problem into small steps that the computer can follow? Let's take the example of the calculator. We didn't just type code randomly, we followed the process. So if you had to describe that process to a human, how would it be? First, we asked the user for a first number. Then, we asked the user for a second number. Then, we asked the user for an operation. Then, we did the math. And finally, we presented the result. That's not code, that's just clear thinking. And that's an algorithm. Coding is just how we translate that thinking into something that the computer understands. You do not need to be a genius, you just need to learn how to describe a solution step by step, like you are giving instructions to a robot that knows nothing. If you skip a step, it will break. If you write the wrong step, it will do exactly that, the wrong thing. So next time you face a problem, ask yourself, what needs to happen first? What comes next? What needs to be repeated? What should I check? So let's do an exercise. So for our simple algorithm exercise, let's do a small program that we will ask 5 numbers to a user, and the result will be the max of those 5 numbers. So let's break it down. First, we will have a list of 5 numbers. Let's call this list input list. Okay? Super easy until now. This would be some code that we'll have to do to iterate 5 times, and every time you ask for a number and you add it to the list. That's fine. Then I know that I will have to compare each single number because the user can insert whatever number they want. Let's restrict to bigger than 0 to avoid complications. But it can be 2 millions, 10, 15, 4 millions. For example, we don't know. So we want to compare each number to reach until the max. We might need a variable to hold the result that we want to compare. So let's do it like that. That variable will be called compare. Okay? And will be of type int and will store the value of a number. Then I will want to iterate on all the list that the user have inputted and compare the number against the compare variable to see if it is bigger or not. Let's make some attributions here to make it more visually. So let's imagine that the user gave us the following numbers: 3, 15, 10, 25, 4. Okay, we have these numbers. Now we will have to iterate on this, and for the sake of making this more visually, each iteration will be the number x, okay, as it's common in math. And it will represent 3, 15, 10, 25, and 4 based on the timing of the iteration. We will iterate x, and then on each iteration we will do the following. Is x bigger than compare variable? If true, we will set compare will be equal to x. If false, we will do nothing. I am sure that this, in the end, when the iteration is finished, compare will have the result of the max value. So we will print compare. Let's make a simple test. So compare starts at 0. Okay, this is important. Now, let's make here a little table. So, first iteration is 3 bigger than 0? True. Then compare equal to 3. Okay. Second iteration is 15 bigger than 3? True. Then compare will be equal to 15. Third iteration is 10 bigger than 15? False. So we do nothing. Fourth iteration is 25 bigger than 15? True. Then compare will be equal to 25. Fifth and last iteration is 4 bigger than 25? False. We do nothing. So the result is 25. And we are correct. This is a very small algorithm to get the max of a number. And as you can see, we made it in 4 steps. And everything in computer science can be done like this. Now I have a challenge for you. Let's see if you can get an algorithm for this case. You have a list of numbers, for example, 5, 4, 11, 44, 2, 3, and 66. And you want to count how many of them are greater than 10. How would you do it? Try to write an algorithm for it. And then next level, try to code it. You will be amazed. Let's have a look of what we have accomplished today. You tested your own code. You upgraded it to handle decimals. You cleaned the logic using a switch statement. You repeated logic with a for and foreach. And finally, you learned how to think in steps, like a real dev. That's huge progress! You are not just copying code. You are learning how to build stuff. Next lesson, we are going to the next level. We will use some advanced logic with ifs and nested conditions and learn about another loop, the while loop. We are going to use methods to clean up our code. We might build a first game, a quiz game. I think you'll like it. And we will add some randomness and tracking score to it. But until then, play with the code, break it, fix it, try new stuff. You are not just learning to code, you are learning to create. And this is the Markov Method, and see you in lesson number 5.